Victoria University is a pace-setting, leading, foremost private university with over 2 decades of excellent delivery of qualitative education with an unbroken academic allegory. Since its inception, the university has championed higher education revolution in Nigeria through innovation, entrepreneurship, bespoke research, and we have grown in leaps and bounds in accordance with the university's motto, which is knowledge and excellence.
My name is Engineer Dr. Mrs. Queenette Adesua Kingsley Omoyibo, a senior lecturer with Mechanical Engineering Department, Igbinedion University, Okada, Nigeria. I am here in Botswana at the International Conference on Smart Application, Communication and Networking 2022. Here in Botswana International University of Science and Technology, Palapie. My topic today is Industry 4.0, a comparative analysis of advanced scheduling and manufacturing software for implementation and adoption in connected factories. For my introduction, I will be talking about the Industry 4.0. Industry 4.0 is this revolution transforming industries using intelligent networking of machines, using ICT, information communication technology, focusing on production, people, plant, environment, and security. Industry 4.0 is offline programming, adaptive control for production. It goes from product design through simulation, then to production. It is a transformative technology in form of Internet of Things. Large number of devices are connected and synchronized with software tools and third platform technologies, digital big data form, artificial intelligence form, using drones. And Industry 4.0 is taking manufacturing to the next level, shaping businesses, efficiency in digital manufacturing, and intelligence. Which of these sectors are affected? Automotive sector, agricultural sector are affected, and now emergence of Industry 4.0. Applying machine learning algorithm is in Industry 4.0. Digitization is in Industry 4.0. Collaborating effort, developing technology separately but working collectively for a virtual world. For definition of terms, we'll be defining manufacturing scheduling software. What is it all about? It is used to collect data, turn this data into actionable output that feeds the connected supply chain, connects machines and computers using sensors for a holistic view of manufacturing facility to boost up production and enhance quality. We'll be defining advanced planning and scheduling software. What is it all about? Delivering goods and services on time, improving throughput, controlling costs, and reducing order to delivery time, stabilizing supply chains, and then modeling manufacturing requirements with digitization strategies. These strategies could be flexible, changeable, agile, and scheduling is another term we're going to talk about, which pinpoints what, pinpoints where, and pinpoints when the production starts, considering constraints, generating a uniform high-quality solution over the entire process of manufacturing. Industry 4.0 is automation and data exchange in manufacturing, using technologies such as cyber physical system, big data, providing prototype design. And then we talk about smart factories. What are smart factories? They are equipped with advanced sensors, embedded software, and robotics, using digital technologies, increased automation, high responsiveness to our customers in our various industries. And so the aim of this industry survey is to comparatively analyze the advanced planning and scheduling manufacturing software that will be able to implement and adopt connected factories. We're going to pursue some objective in this study, which is to establish the efficiency of the design that has been used, which is the concurrent triangulation design, using this model as a tool to compare, to analyze, and to determine the key enablers that will be adopted and implemented for Industry 4.0 in connected factories, using 10 factories as our case study. And then to comparatively analyze and select from these advanced manufacturing software we have chosen and the key enablers to be used to implement and adopt Industry 4.0 for a connected factory, and then monitor digital transformation of these industries and to supervise the migration from the old traditional system of reconfigured manufacturing to the Industry 4.0. We looked at some literature review. One of it was to check the implementation, a study that looked at the implementation of Industry 4.0 using agile processes, optimizing production through configuration of technologies, of course, modular technologies for digitization. But this study did not look into adoption in Industry 4.0. It was studied by J. Kin, Q-I-N, et al. In 2016. And in 2017, Mari Lungo looked into cyber physical system using seamless migration of computational algorithms to produce wireless sensor network, but did not look into the adoption and implementation of. Hence, materials and methods were set up, and this material method was set up to conduct industry survey with 10 factories in Nigeria to ascertain the opinion of industry captains using a model called the concurrent triangulation design. The concurrent triangulation design had to do with having survey questions, distribute the survey questions, use descriptive statistics to analyze the survey questions. It has a phase 1 and a phase 2. The phase 1 dealt with the quantitative part, which has to do with distributing the questionnaires, retrieving the usable questionnaires, analyzing these usable questionnaires, and then recording the results. The in-depth interview was conducted for 50 respondents in the phase 2, which is the qualitative phase, and then the results were collated. Phase 1 and phase 2 results were the final result collated, validated using comeback alpha. Rule of thumb for reliability testing was 0 greater than 0.9 to be excellent, and all the values were in the range of 0.9. So comeback alpha values recorded for 0.99147 were for the respondents that were of the view that optimizing supply network costs and implementing a complete order allocation using production scheduling sequencing was chosen over other key enablers as the most preferred in all those key enablers. So, results. The results from reliability testing using comeback alpha values checked the internal consistency of all the results that were recorded. And so what happened? 0.991479 respondents talked about, were of the opinion that using production scheduling software was better. 0.988140 respondents were of the opinion that using real-time optimization was what they chose. But the 0.97910 respondent chose using production planning software. And lastly, 0.970950 respondents were of the view that optimizing workforce with production sequencing was most preferred. But conclusively, results from phase 1, from a total of 450 respondents with 400 respondents for industry survey questionnaires, closed-ended questions, and 50 respondents for in-depth interview, 34.22 respondents agreed that production planning was best. 33.78% respondents were of the view that production scheduling software was what they chose, and then 17.33% respondents chose real-time optimization. Lastly, 14.67% respondents were of the view that production sequencing manufacturing software would help to keep our industries connected. Optimized value of alpha value at 0.99147 with 147 items with 34.22% embraced the Industry 4.0 and the adoption of Industry 4.0 for connected factories. These results has therefore shown us the light that if Industry 4.0 is adopted, it will help to keep pace with industry-leading digitization practices when fully implemented and adopted for connected factories. So adopting and implementing Industry 4.0 for a connected factory using advanced planning and scheduling software will help to improve, one, throughput of our industries in Nigeria, in Botswana, and even in the world, and then to stabilize supply chains, enhance self-adapting manufacturing capabilities. Adopting Industry 4.0 will help to take our industries to the next level. Thank you very much for listening. and God bless you. See you at the question and answer session. Thank you.